when we talk about the complex number, we said like, okay, the complex number is written, the symbol for the complex number is Z, and it's written as A plus BI, where the first one is the real, we said that one is the real part, and the second one is the imaginary part. Okay, that's how we define the complex number. Now, we want to find out what is a polar form. The polar form of a complex number is written in like that, R angle theta, where R is the magnitude and theta is the direction. Someone just said it's an argument. Yes. Argument and magnitude, they are same thing. Yeah? Okay. Now let's have a look. How do we convert a complex number into the polar form? Let's say I got a complex number Z. Convert complex number Z equals 3 3 plus 4i into polar form. So, how we do that? First we need to find the R. Now what is actually R is? R is A plus A square plus a B square square root. That's what the R is. And you know what's A, what's B. We find the R because the complex number is written in the form of A plus a BI. So the A is 3 and the B is 4. And then we got the theta. Theta equals tan inverse B over A. B over A. Now I got two formulas. I can use these two formulas to actually find my R and find my theta. Let's do that one. If I use that thing here, that will be a 3 square plus a 4 square square root. If I put that in calculator, I will have an answer 5. And now I want to find the theta. So tan inverse 4 over 3. And I will have my value for the theta. Degrees, yeah? So the theta is 53.1 degrees. If I want to write it down now, I got almost everything. Okay, let's use this one. Okay, so if I want to write in this form, R angle theta. Okay, R is 5. Angle theta is 53.1 degrees. So I've just converted a complex number into a polar form. Argand diagram. Now what is an Argand diagram? Argand diagram is a way of representing a complex number on a graph. When we talk about, we know the Cartesian form. Now what is Cartesian form? Well, when I said like A plus, let's say when Z equals to 2 plus 3i. This is known as Cartesian form. Cartesian mean on a two Cartesian x and y plane, and then I converted that into a polar form. Let's say if I write something like 6 angle 20 degree, this is a polar form. So Cartesian form, polar form. Now you can actually plot, if I go back, let me just copy the one from here so it's much better. I got 3 plus 4i. So let's say if I got 3 plus a 4i, which is exactly same as what you got here, which is 5 angle 53.1. So 5 angle 53.1 degree. If you got a graph paper, on the graph paper, this is how we actually plot. Okay, on the graph paper, if I want to plot that one, this axis is known as imaginary axis. So this is the I-axis. This side is going to be minus I, and this is a real axis, and this is going to be the negative real axis. So on this one, let's say if I properly do like 1, 2, 3, 4, 5, 6, and I do 1, 2, 3, 4, 5, 6, and the other side as well, you know. So I just, let's say on a proper graph. And I want to plot this thing, 3 plus 4i. So 3, I need to move the 3. 1, 2, 3. That I'm here, 1, 2, 3. And then 4 up. 1, 2, 3, 4. So it's going to be somewhere here. And if I join that with the, oops, sorry, not like that way. If I join that with a straight line, yeah, and I measure the line, if this is 1 centimeter, this thing is 1 centimeter, when I measure the line, this is going to be the R, which is that case is 5, and if I measure the angle theta, that is going to be 53. That's going to be 53, oh sorry, it was 0.1. 53.1 degree. Yeah. So if you do that, exactly same answer. This is we can actually plot the complex number on an Argand diagram, and this diagram is called Argand diagram. If that was okay, what's the conjugate of 3 plus 4i? Anyone? Conjugate of 3 plus 4y?
3 minus 4i.
3 minus 4i. Okay, conjugate. I'm going to write the conjugate here. So this thing is 3 plus 4i. Yeah. Now the conjugate is 3 minus 4i. Done. So let's plot 3 minus 4i. 1, 2, 3, but 1, 2, 3, 4. So it's going to be like, yeah. The angle is still going to be same, but when you do the angle is 53. Now when you measure the angle that way, clockwise, when you measure anti-clockwise, it's positive. When you measure clockwise, it's negative. So the angle here is still 53, but minus 53. That's how we do that one. So clockwise angle is a negative, and anti-clockwise angle is a positive. Yeah. But it will still have the same magnitude. Yeah. So that's the odd. And this is 3 minus 4i. Yeah. So you can see they are conjugates of each other. So if you convert these into polar forms, 7 plus 8i, minus 3 plus 2i, minus 9 minus 4i, 5 minus 7i. Remember, when we did the tan, obviously with the r magnitude, it's not gonna, it will not affect anything. So when you do the r, the formula for the r is going to be, I will clear that one. The formula for the r is a square plus b square. Now I put the bracket. Why? Because here when you do the a value is 7, the b value is 8. But when you do the a value here, it's minus 3. So if you do minus 3 square like that, it will give you the answer minus 9. But if you do minus 3 and square, that's how you should do the second one. It will give you the answer 9. So that's how you should do that one. Okay, I'm just going to clear this one. Yeah. So that's not a problem. R is not a problem. Okay. What about the tan? When you do the tan, like a theta, which is equal to tan inverse, it's B over A. But when you do that one, for example, in this case, the B is 2 and the A is minus 3. So make sure you do put that one here. Yep. And that will give the value of the theta. So try that one and then I will help you. I will solve these ones for you. Okay, let's start with these examples. 7 plus 8i. How we are going to do this one. Okay, 7 plus 8i, that's the easy one. Now this is an A and this is a B. So I need to convert into polar form. So I need to write in this form R angle theta. When we write the angle, it's not like that crocodile sign. Yeah, it's that and then straight. Yeah, that's how we just put that one. So we need to write in that. So I need to find the R and the theta. To find the R, it's the A square plus a B square square root. 7 square plus a 8 square square root. I'm not putting brackets because there is no negative sign, so otherwise I'll put brackets. Can someone give me the answer, please?
Root 113.
And if you press ST button, decimal please. 10.6. Okay, 2 decimal places, but okay, we find here. So 10.6. So I'm gonna put that one 10.6. But always use 2 decimal places. Now I need to find out the angle theta. To find the angle theta, I know I have a formula. Tan inverse B over A. Now put the values. Tan inverse. What's the B? Can someone do that one, please?
48.8.
48.8.
Yeah.
So that will be 48.8 degrees. Okay. Now, before I start something, let's have a look at where is it's going to be. If I draw a graph, this is my graph, yeah. There is a thing in the graph, it's called cast, C-A-S-T. You guys heard of that one? Cast, C-A-S-T. Okay, I'll do the cast later. But before I do that one, this is a positive axis and this is a positive, isn't it? If x is positive and y is positive, it's going to, the number will be here in this quadrant, yeah? So this, we call this one as first quadrant. Oh, that's not first. Let me just write this one again. Little bit smaller version on the slide. So this is positive, positive. If A is positive, B is positive, it's here. This is positive, this is negative. And this is negative as well. If B is negative, B is positive, A is negative, it's going to be in this quadrant. This is called the first quadrant. This is called the second quadrant. If both are negative, it's in third quadrant. And that's in fourth quadrant. That's how it works, yeah? So in this case, it was 7 was positive. So 1, 2, 3, 4, 5, 6, 7. So let me just do this one black. Okay, 1, 2, 3, 4, 5, 6, 7 up till here. And then 1, 2, 3, 4, 5, 6, 7, 8. So something here. So that would be my theta, which is 48.8. And if I measure that length, it will be 10.6. Yeah, if I do to the scale. So this is the first one. Now let's have a look at the second one. Second one. What was the second one? Minus 3 plus 2i. Minus 3 plus 2i. First, well, I need to convert into this form. First, I need to find the r. Because that's the formula for the r, a squared plus b squared. A is that, b is that. Can someone give me the value for the r, please? In decimals?
3.61.
Thank you. I have the r. Now I need to find out the theta. Tan inverse b over a. Theta equals to tan inverse. What's the b? What's the a? Yeah. Anyone give me a answer, please?
Minus 33.7.
Minus 33.7. Everyone got the same answer?
Yeah.
Okay. Now let's have a look. Let's have a look. What is this? And we need to find out where it is. Okay. Here you go. Now you know this is a positive real, negative real, positive I, and positive I and a negative I. You know that one, yeah? Okay. So minus 3. So let's plot minus 3 on there and just find out where it is. Minus 3. 1, 2, 3. Minus 3 is going to be here, and then 2, 1, 2. So it's going to be something like this, isn't it? Yeah? And we have just found, because the angle is minus 33, so which means this angle is minus 33. Because you make clockwise. So this angle is minus 33.7 degrees. Because when we measure the angle clockwise, we take it negative. Yep, so we start from here, this angle is that one. But the angle we need is this angle. This is the angle we should write here. This is the angle we need. And we know it exists in the second quadrant. So what's the total angle in a straight line? The total angle in a straight line is 180. So total angle in the straight line is 180 degree. So you do 180 minus this. What's the answer? Anyone give me the answer?
146.3.
So say again?
146.3.
So that will be this angle. 146.3 degree. So when you write that angle here, oh sorry, my mistake. When you write that angle here, that will be 3.61 angle. You need to write that one, this angle, not this angle. Yeah?
So can you never have a negative number for theta in this?
You can have, but the negative mean negative 33.7 can be here as well.
Okay.
So you need to kind of think about which quadrant it is. And then we use from that. Because it can't be in third quadrant, so angle should be less than 180, isn't it? It's in second quadrant, so angle should be between 90 and 180. Because when you look here, let me go to the next one maybe. In the first quadrant, the angle goes from, let's say, from 0 to 90. In the second quadrant, it's 90 to 180. In the third quadrant, it's 80 to 270. In that quadrant, it's 270 to 360. Yeah, that's how it works. This is how we know like which quadrant it is. Yeah.
So should you always write it theta as from like
Yes.
Okay.
So whenever you measure the angle, you always measure the angle from here. Yeah.
Darn it.
That's how we measure the angle. Okay, let's say we got these complex numbers. And now we need to convert this complex number into a polar form. So the first thing you need to find the r. R has a formula, a squared plus b squared. Okay, we know that one. Now let's put that in the formula. So r equals to minus 9 square plus minus 4 square. So make sure they are in minus in the bracket. Can anyone give me the answer please in decimal?
9.85.
9.85, thank you. Yeah, good, 2 decimal places. Okay, so this is my value of the r. Done. Now I need to find out the theta. So theta equals to tan inverse b over a. Now put the values. Tan is tan. And what's the value for the b? Minus 4. And what's the value for the a? Minus 9. Can someone give me the answer please?
23.96.
23.96, yeah? Okay. Now, let's find out where it is and what's the real angle. Okay, so because it's this is positive, positive, this is negative, negative, yeah? So it means it should, because the both values are negative, it should exist in that one. See, minus 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, minus 9, and minus 4. 1, 2, 3, 4. So it should exist in the third quadrant, somewhere here. And the value I got, so what was the value, minus or positive? Positive 23, yeah?
Yeah, positive.
So positive 23, when I measure the value, it should be like this value. This is a 23.9 degrees, yeah? Or let's 26.96, or I can say 24 degrees, yeah? Because see, I'm measuring that one. But the real angle, the one I need, should start from here. So let's measure the angle. Yeah, so what will be the angle then?
203.96.
How come, please? Can you explain?
Because you need to add 180.
Thank you. Yeah, can you give me the value again?
203.96.
Yeah, why you add 180? Because he knows that we have to start from here. So this is 180 and we have to add that one. So that is the full angle. That's the full angle. Okay, now we got that bit. So now that will be 9.85 angle 203.96 degree. You can call 204, yeah, if you want to. 1 decimal is good. Okay, let's have a look at this one. Number 4, 5 minus 7i. And let's see if we can. That was simple. Okay. Now 5 minus 7i. So let's find out. So first thing we need to do is we need to find the r. R is a square plus b square. You guys know that formula. R is 5 square plus minus 7 square. Can someone give me the value for the r, please?
8.60.
8.60. Thank you. Okay, so the r is done. Now we need to find angle theta. What's the, oops, sorry. Oh, okay, doesn't matter. What's the b? Minus 7. What's the a? 5. Can someone give me the value, please? Just the theta, please.
Minus 54.5.
Excuse me. Minus, thank you. 54.5.
5.
Thank you very much. That's it. Now, if we have a look at, okay, where is this thing actually lies? Which quadrant? Now let's have a look. So let me just change the color. So this is going to lie 5 minus 7. So 5, 1, 2, 3, 4, 5 and minus 7 here. So it's going to lie in this quadrant. And the angle is minus 54, which means like it's that way, it's minus 54.5 degree. I don't need that angle. The angle I really need is a proper angle, which is that one. So what should I do? 360 minus 54.5. What's the angle? Can someone give me the value for the angle, please?
305.5.
So then this thing will be R angle 305.5 degrees. Okay, so these are some practice questions. You need to do that one. You also need to plot an Argand diagram as well. Plot Argand diagram. Before you plot Argand diagram, you need to convert into polar form. And follow the steps that we did, and I think you all will be okay.